Which of the following is true about the base estimator class in scikit-learn? A. It defines the basic structure for all scikit-learn estimators. B. It provides essential methods like fit and predict. C. It is a fundamental class that serves as a blueprint for model development. D. All of the above. True. The base estimator class acts as a foundational structure for all scikit-learn estimators, defining their basic structure and providing a common framework for model development. True. The base estimator class lays down essential methods like fit for training a model and predict for making predictions, crucial for model training and evaluation. True. As the cornerstone of scikit-learn's estimator framework, base estimator serves as a blueprint for model development, allowing for consistent model creation and integration. True. All the statements in choices A, B, and C are true regarding the base estimator class in scikit-learn. D. All of the above. Estimator, transformer, fit method, predict method, model selection. What is the primary role of the bicluster mixin base class in scikit-learn for biclustering? A. Provides a foundation for biclustering algorithms by defining essential methods and attributes. B. Implements a specific biclustering algorithm, like spectral biclustering. C. Performs data preprocessing for biclustering, such as normalization. D. All of the above. True. The bicluster mixin acts as a base class for developing biclustering algorithms, providing a standardized framework with essential methods and attributes. This helps ensure consistency across different algorithms and simplifies implementation. True. While bicluster mixin provides a foundation, it doesn't directly implement specific algorithms. Algorithms like spectral biclustering inherit from bicluster mixin and implement their unique logic. True. Data preprocessing, including normalization, is often necessary for biclustering. While bicluster mixin doesn't handle preprocessing itself, it provides an interface for incorporating preprocessing steps within specific algorithms. True. All of the above statements are true. Bicluster mixin provides a foundation for building biclustering algorithms, allows for implementing specific algorithms, and facilitates data preprocessing. D. All of the above. Discovering submatrices within a data matrix where rows and columns exhibit similar patterns. Analyzing gene expression data to identify groups of genes and samples that are co-regulated. A base class in scikit-learn that provides a blueprint for biclustering algorithms, defining common attributes and methods. Simplifies the development of new biclustering algorithms by inheriting from bicluster mixin and implementing specific methods. A biclustering algorithm that utilizes spectral graph partitioning to identify clusters, discovering coherent patterns in data with complex relationships, often used in document analysis or image segmentation. Transforming data to ensure consistent scales and distributions to improve biclustering performance. Handling data with disparate ranges or units, preventing certain features from dominating the biclustering process. A common preprocessing technique to scale features to a specific range, often between 0 and 1, to ensure equal weight. Preventing features with large magnitudes from overshadowing features with smaller magnitudes in biclustering. The bicluster mixin serves as a foundational class for creating and implementing biclustering algorithms in scikit-learn. It provides a framework that defines essential methods and attributes common to all biclustering techniques. By inheriting from bicluster mixin, developers can avoid redundant code and focus on the unique aspects of their specific algorithm. Examples: Spectral biclustering implements spectral biclustering based on graph partitioning, utilizing bicluster mixin for core functionality. Direct biclustering, another biclustering algorithm built upon the bicluster mixin structure. What are the key attributes and methods provided by the classify mixin class in scikit-learn? Which enhances the functionality of classifiers? A. Classes, predict proba, score, decision function, predict. B. Fit, predict, score, predict proba. C. Predict, score, decision function, transform. D. All of the above. True. Classes, predict proba, score, decision function, and predict are all key attributes and methods provided by the classify mixin class. Classes stores the unique class labels. Predict proba returns probability estimates for each class. Score calculates the accuracy. Decision function provides raw decision scores. And predict makes predictions on new data. True, fit, predict, score, and predict proba are all essential methods provided by the classify mixin class for training, prediction, evaluation, and probability estimation. True, predict, score, decision function are all provided by the classify mixin class. However, transform is not related to the classify mixin. Transform is typically associated with transformers used in preprocessing or dimensionality reduction. True. All the mentioned methods and attributes classes, predict proba, score, decision function, predict, fit, transform are provided by the classify mixin class, making option D correct. D. All of the above. A base class in scikit-learn providing essential methods and attributes for building classifiers. The parent class for all estimators in scikit-learn. It defines common functionalities like fit, predict, and score, a type of machine learning where the algorithm learns from labeled data inputs and corresponding outputs to make predictions on unseen data. A machine learning task where the goal is to categorize data points into predefined classes. The process of creating a model that can predict future outcomes based on past data. The process of assessing the performance of a trained model using various metrics like accuracy, precision, recall, etc. A metric that measures the proportion of correctly classified data points. The likelihood of a data point belonging to each class, provided by methods like predict proba. A function that outputs raw scores for each class, providing insights into the classifier's internal workings. The unique categories or classes that the classifier is trained to distinguish. What does the cluster mixin in scikit-learn primarily provide? A base class for building custom clustering algorithms. B. Methods for evaluating the quality of clustering results. C. A set of predefined clustering algorithms. D. All of the above. True. The cluster mixin is specifically designed as a base class to help you create your own custom clustering algorithms in scikit-learn. It provides fundamental building blocks and methods that are commonly required in clustering tasks. You inherit from this class to define the core logic of your unique clustering algorithm. False. While evaluating clustering results is crucial, the cluster mixin itself doesn't directly offer methods for this. You'd typically use separate functions or metrics from scikit-learn or other libraries for evaluating clustering performance. False. The cluster mixin doesn't contain any predefined clustering algorithms. It's meant to be a foundation for building your own custom clustering algorithms, not a library of ready-made algorithms. False. Since options B and C are incorrect, option D is also incorrect. The cluster mixin primarily provides the foundation for creating custom algorithms, not evaluation methods or predefined algorithms. A base class for building custom clustering algorithms. Clustering is the process of grouping similar data points into clusters based on their characteristics. Popular examples include k-means and DBSCAN. Clustering is a key technique in unsupervised machine learning, where the goal is to discover patterns and structures in data without explicit labels. It's used in various applications like customer segmentation, image analysis, and anomaly detection. Base classes provide a foundation for building more complex classes or algorithms by inheriting from them. They offer essential methods and properties that are commonly used in a specific domain. The cluster mixin in scikit-learn serves as a base class specifically designed for building custom clustering algorithms. It provides common methods and properties required for defining the core logic of your custom clustering algorithms. The cluster mixin streamlines the process of developing new clustering algorithms by offering a structure and fundamental functionalities, allowing you to focus on the specific logic of your algorithm. Custom clustering involves tailoring clustering algorithms to specific data requirements or objectives, potentially incorporating domain-specific knowledge. This is often needed when standard clustering algorithms don't adequately capture the unique characteristics of your data or when you need to consider specific constraints in the clustering process. The cluster mixin enables you to create entirely new clustering algorithms tailored to unique data structures or objectives. You might create a new clustering algorithm that is particularly suited for handling very large datasets with high-dimensional data points. You can use the cluster mixin to modify existing clustering algorithms to incorporate domain-specific knowledge. You could extend k-means to consider a custom distance metric that is more relevant to your particular dataset. The cluster mixin allows you to define distance functions tailored to specific data characteristics. In some scenarios, standard Euclidean distance might not be the best measure of similarity. You could define a new distance metric based on your domain expertise. Which of the following is not a valid use case for the sklearn base density mixin class? A. Anomaly detection. B. Data visualization. C. Density-based clustering. D. All of the above. True. The sklearn base density mixin class provides a framework for implementing density estimation methods. It offers core functionalities for calculating the probability density function PDF of data and can be utilized for a wide range of applications. Density estimation is a key technique for anomaly detection. By estimating the density distribution of normal data, anomalies can be identified as points with low probability density. The density mixin class provides a foundation for implementing anomaly detection algorithms. True. Visualizing the density distribution of data helps understand its underlying structure. Density plots and contour maps created using the density mixin can provide valuable insights into the concentration and distribution of data points. True. Density-based clustering algorithms like DBSCAN leverage the concept of density estimation to group data points based on their spatial proximity in density. The density mixin provides foundational support for implementing such clustering algorithms. False. The sklearn base density mixin class is a useful tool for density estimation and can be applied in anomaly detection, data visualization, and density-based clustering. Hence, all the mentioned options are valid use cases. So, the answer is D. All of the above. D. All of the above. Density estimation. sklearn base density mixin. anomaly detection, data visualization, density-based clustering. Which of the following statements accurately describe the role of the regressor mixin class in scikit-learn? A. It provides a base structure for all regression models in scikit-learn, enabling efficient implementation and consistent API. B. It offers methods for fitting and predicting continuous target variables, facilitating the core functionalities of regression. C. It integrates with other scikit-learn components seamlessly, ensuring a cohesive and streamlined workflow. D. All of the above. True. The regressor mixin class serves as the foundation for all regression models in scikit-learn. It defines the essential methods and attributes that are common to all regression algorithms. This approach provides a consistent structure and interface for regression models, ensuring they operate seamlessly within the broader scikit-learn ecosystem. True. The regressor mixin provides the fit method for training the model on the training data. Once trained, the model can use the predict method to generate predictions on new, unseen data. These methods form the core functionalities of any regression model, allowing them to learn from data and make predictions. True. The regressor mixin ensures smooth integration with other scikit-learn components. This seamless interaction streamlines model development and workflow. For example, regression models can be seamlessly incorporated into pipelines, enabling automated feature engineering and model selection. Furthermore, they can be used with cross-validation techniques for robust model evaluation. True. All the statements A, B, and C accurately describe the role of regressor mixin class in scikit-learn. It provides a base structure for all regression models, offers methods for fitting and predicting continuous target variables, and seamlessly integrates with other scikit-learn components. D. A foundational class in scikit-learn that defines the core structure and functionality for regression models. It provides a standardized approach for creating and using regression models in scikit-learn. Statistical methods used to predict continuous target variables. These models aim to establish relationships between input features and the output variable. A method used to train a machine learning model on a dataset. It learns the patterns in the data to make predictions later. A method used to generate predictions on new data using a trained model. It applies the learned patterns from the training data to the new data. The ability of regressor mixin to work cohesively with other scikit-learn components like pipelines and cross-validation, streamlining model development and workflow. What is the primary purpose of the transformer mixin class in scikit-learn? A. Provides a standardized interface for transforming data in a pipeline. B. Enables data scaling for feature engineering. C. Facilitates model selection by comparing different transformers. D. All of the above. In the heart of scikit-learn lies transformer mixin, a fundamental class that empowers data transformation. This choice is correct because transformer mixin provides a standard framework for data transformation, which is crucial for pipelines. Pipelines automate machine learning workflows by chaining together different steps, including transformers and estimators. True. 1. LTBGT feature scaling. LTBGT transforming features to a common scale, e.g. standard scalar, min-max scalar. This choice is correct. Feature scaling is a common data transformation technique, often used for feature engineering. Transformer mixin serves as the foundation for classes like standard scalar and min-max scalar that perform feature scaling. True. 1. LTBGT pipeline. LTBGT, a sequence of transformers and estimators to automate machine learning workflows. While transformers are crucial for model selection, Transformer mixin itself doesn't directly facilitate model selection. It provides the building blocks for creating transformers. But the model selection process typically involves evaluating the performance of models after applying transformers within a pipeline. False. In the heart of scikit-learn lies transformer mixin, a fundamental class that empowers data transformation. This choice is correct. Transformer mixin provides a standardized interface for transformation, enabling data scaling for feature engineering. It's not directly involved in model selection itself. However, it supports the overall process by providing the foundation for data manipulation. True. D. All of the above. Pipeline, estimator, data transformation, feature engineering, model selection, standard scaler, min-max scaler, PCA, truncated SVD, one-hot encoder, ordinal encoder, custom transformer. What is the primary purpose of method estimator mixin in scikit-learn? A. Facilitates building custom estimators with the same interface as scikit-learn's built-in estimators. B. Provides a way to create ensemble models by combining multiple estimators. C. Enables the optimization of hyperparameters for an estimator. D. All of the above. True. The method estimator mixin is a core component of scikit-learn's design, playing a crucial role in maintaining a consistent interface for various types of machine learning estimators. LT font style font size 12px GT LTBGT custom estimators LTBGT LT font GT LT font style font size 12px allows you to build new estimators by inheriting from the mixin, automatically adopting the scikit-learn interface. LT font GT estimator interface. True. The method estimator mixin is a core component of scikit-learn's design, playing a crucial role in maintaining a consistent interface for various types of machine learning estimators. LT font style font size 12px GT LTBGT ensemble methods LTBGT LT font GT LT font style font size 12px provides a foundation for creating ensemble models like random forests, bagging, and boosting, which combine multiple estimators. LT font GT ensemble methods. True. The method estimator mixin is a core component of scikit-learn's design, playing a crucial role in maintaining a consistent interface for various types of machine learning estimators. LT font style font size 12px GT LTBGT hyperparameter tuning LTBGT LT font GT LT font style font size 12px although method estimator mixin doesn't directly handle hyperparameter tuning, its consistent interface makes it easier to integrate with hyperparameter optimization libraries. LT font GT hyperparameter tuning. True. All the above are true. The method estimator mixin facilitates building custom estimators with the same interface as scikit-learn's built-in estimators. It also provides a way to create ensemble models by combining multiple estimators. While it doesn't directly handle hyperparameter optimization, its consistent interface makes it easier to integrate with hyperparameter optimization libraries. All of the above. D. All of the above. Estimator interface, custom estimators, ensemble methods, hyperparameter tuning. Which of the following statements accurately describes the purpose of scikit-learn's one-to-one feature mixin? A. Transforms multiple features into a single new feature. Applies a transformation to a single feature, creating a new feature with the same dimensionality. False. This statement describes how one-to-one feature mixin works, but it doesn't encompass all its capabilities. It can also combine multiple features and apply transformations to a single feature, resulting in a single new feature. B. Applies a transformation to a single feature, creating a new feature with the same dimensionality. A base class for transformers that operate on a single feature at a time, creating a new feature with the same dimensionality. True. This statement is correct. The key purpose of one-to-one feature mixin is to apply transformations to individual features while maintaining the original data's shape, ensuring the output has the same dimensionality as the input. C. Combines multiple features into a single, more informative feature. Combines the outputs of multiple transformers into a single feature space. False. This statement describes the function of feature union, not one-to-one feature mixin. Feature union is used to combine multiple transformers, while one-to-one feature mixin focuses on single feature transformations. D. All of the above. Transforms multiple features into a single new feature. True. This choice accurately reflects all the capabilities of one-to-one feature mixin. As explained in the previous explanations, it can transform single features, combine multiple features, and result in a single new feature. D. All of the above. Feature engineering. The process of transforming raw data into features that are more informative and suitable for machine learning models. Extracting day of the week from a date feature. Feature transformation. Applying mathematical or statistical operations to existing features to create new features with potentially improved predictive power. Scaling features using standardization or normalization. Scikit-learn's one-to-one feature mixin. A base class for transformers that operate on a single feature at a time, creating a new feature with the same dimensionality. Function transformer to apply a custom function to each feature. Feature transformer. An object that transforms features into a different representation. Scikit-learn pipeline. A way to chain multiple transformers and estimators together for a streamlined workflow. Feature union. Combines the outputs of multiple transformers into a single feature space. Transformer. An object that modifies the input data to create a new representation. Estimator. An object that can learn patterns from data and make predictions. Examples of transformers. Standard scaler. Min-max scaler. One-hot encoder. Function transformer. Examples of estimators. Logistic regression. Decision tree classifier. Random forest regressor. Linear regression. Which of the following methods are defined in the sklearn base outlier mixin class? A. Fitx, unan. B. Fit-predictix. C. Decision function x. D. All the above. Correct. The Fitx, unan method is defined in the sklearn base outlier mixin class. It trains the outlier detection model on the input data x. It learns the underlying distribution or patterns in the data to identify outliers. The y argument is optional and is not used in the outlier detection process. Correct. The fit-predictix method is also defined in the sklearn base outlier mixin class. This method combines the fit and predict steps. It first trains the outlier detection model on the input data x and then predicts the outlier labels for each sample in x. The output is a 1D array of labels, where 1 indicates an outlier and -1 indicates an inlier. Correct. The decision function x method is defined in the sklearn base outlier mixin class. This method returns the decision function values for each sample in the input data x. The decision function represents the distance or score that indicates how likely a sample is to be an outlier. Higher scores generally correspond to outliers, The specific meaning and interpretation of the decision function values can vary depending on a underlying outlier detection algorithm. Correct. Since A, B, and C are all defined in the sklearn base outlier mixin class. Option D is the correct answer. D. All the above. Outlier, anomaly, noise, data distribution, decision function, in-layer, outlier detection algorithm. In scikit-learn, which class in the sklearn base module is responsible for defining the output format when a feature transformation is applied to the input data? A. Transformer mixin. B. Base estimator. C. Class name prefix features out mixin. D. All of the above. Transformer mixin defines the fit and transform methods, but it doesn't specifically address the output format of transformed features. False. Transformer mixin defines the fit and transform methods common to feature transformers. Base estimator provides basic functionalities for estimators, not related to the output format of feature transformations. False. Base estimator base class for all estimators in scikit-learn, providing basic functionalities like parameter initialization. Class name prefix features out mixin is the base class that specifically defines the output format for feature transformations. It adds a prefix to the feature names using the transformers class name, ensuring clear and structured output. True. LT font color (blue) class name prefix features out mixiled font GT is the base class in scikit-learn that defines the output format for feature transformations. This ensures consistency and clarity in how transformed features are named and handled. It's designed to automatically add a prefix to the feature names of the output dataset, providing a structured approach to working with transformed features. The prefix used is the class name of the transformer, making it straightforward to identify which transformations have been applied. Only class name prefix features out mixin is responsible for defining the output format, not transformer mixin or base estimator. False. None. C. Class name prefix features out mixin, a base class in scikit-learn responsible for defining the output format of feature transformations. It adds a prefix to the feature names using the transformers class name, ensuring clear and structured output. Feature selection ensures selected features are properly labeled with the transformer's name. Feature engineering helps maintain clear and organized feature names during custom transformations. Pipeline management enables easier tracking of feature transformations throughout pipelines. Defines the fit and transform methods common to feature transformers. It's responsible for fitting the transformer to the data and transforming the input data accordingly. Base class for all estimators in scikit-learn. It provides basic functionalities like parameter initialization and the ability to set and get parameters. A sequence of estimators, typically including feature transformations and a final estimator. Pipelines simplify the process of building complex machine learning models. You want to create a custom estimator in scikit-learn that inherits from a base estimator but also utilizes the power of another existing estimator. Which of the following methods is used to accomplish this? A. Clone. B. Clone estimator. C. Clone. D. Clone model. This method is not directly used for creating custom estimators. It primarily serves for creating independent copies of existing estimators, ensuring that modifications to one copy do not affect the others. Key concepts. This is the core method for creating custom estimators. It takes an existing estimator as input and returns a copy that can be modified to incorporate a desired functionality. Key concepts. This is not a valid method in scikit-learn. The correct method for cloning estimators is clone estimator. Key concepts. This is not a standard scikit-learn method. The method used for cloning and modifying estimators is clone estimator. Key concepts. B. Clone estimator. Base estimator. The foundation of custom estimators in scikit-learn. Defines essential methods like fit, predict, score etc. Key concepts. Custom estimator. User-defined estimators that extend the functionality of base estimators. Often incorporate existing estimators for specific tasks. Key concepts. Clone estimator. A core function for copying and modifying estimators, enabling creation of customized versions. Key concepts. Enhancing existing estimators. Building a custom estimator that uses a pre-trained random forest model for feature selection before applying a logistic regression model. Use cases. Creating hybrid models. Combining different estimators like a support vector machine for classification with a linear regression for regression in a single model. Use cases. Specialized applications. Developing estimators for unique tasks like time series forecasting or anomaly detection. Using underlying estimators like ARIMA or isolation forest. Use cases. Which of the following statements are true regarding the isClassifier attribute in scikit-learn? A. It is a Boolean attribute that helps determine if a scikit-learn estimator is a classifier. B. It can be used to identify models that predict categorical labels. C. It is available in the sklearn base module. D. All of the above. True. The isClassifier attribute is indeed a Boolean value, returning true if the estimator is a classifier and false otherwise. This attribute helps in identifying whether an estimator is designed for classification tasks. True. Classifiers are specifically designed to predict categorical labels, such as spam or not spam, cat or dog. The isClassifier attribute helps identify these models that handle categorical predictions. True. The isClassifier attribute is part of the sklearn base module. This module provides fundamental classes and utilities for building and working with machine learning models in scikit-learn. True. As statements A, B, and C are all true, the correct answer is D. All of the above statements accurately describe the isClassifier attribute. D. All of the above. sklearn base estimator. sklearn base classifier mixin. sklearn base isClassifier. sklearn base regressor mixin. sklearn base isregressor. sklearn metrics accuracy score. sklearn metrics mean squared error. sklearn metrics R2 score. sklearn model selection train test split. In machine learning, classifiers and regressors are two types of supervised learning algorithms. Classifiers predict categorical labels, such as spam or not spam, cat or dog. Regressors predict continuous values, such as the price of a house or the temperature of a city. The sklearn base module provides fundamental classes for building machine learning models in scikit-learn. This module defines common base classes that various estimators inherit from. Base estimator. This class serves as the foundation for all scikit-learn estimators. It provides methods like getParams and setParams for managing estimator parameters. Classifier mixin. This class is designed to work with classifiers. It introduces the predictProba and predictLogProba methods to predict class probabilities. The isClassifier attribute is a Boolean property that helps determine whether a scikit-learn estimator is a classifier. It checks if the estimator inherits from the classifier mixin class. Imagine you have a library of machine learning models and need to select only the classifiers for a specific task. Using the isClassifier attribute, you can filter the models based on their classification capabilities. Which of the following is true about the base estimator class in scikit-learn? A. It defines the basic structure for all estimators in scikit-learn. B. It provides essential methods like fit and predict for model training and prediction. C. It ensures consistency in the way estimators handle hyperparameters. D. All of the above. Correct. Base estimator serves as a blueprint, establishing a common structure for all estimators in scikit-learn, ensuring consistency and making it easier to develop and maintain models. The base estimator serves as a blueprint for all estimators, dictating a consistent structure that facilitates model development and maintenance. Correct. Base estimator offers fundamental methods like fit and predict. The fit method is used to train the model on the input data, while the predict method utilizes the trained model to make predictions on new data. Key methods like fit and predict are provided by the base estimator. The fit method is responsible for training the model on the input data, while predict utilizes the trained model to make predictions on new data. Correct. Base estimator encourages consistent handling of hyperparameters, which are parameters that control the model's structure and behavior. This standardization makes fine-tuning models more uniform. The base estimator promotes consistent handling of hyperparameters, which are parameters that define the model's structure and behavior. This ensures a standardized approach to fine-tuning models. Correct. All the statements A, B, and C are true regarding the base estimator class in scikit-learn. The base estimator class is the cornerstone of scikit-learn's estimator framework. It provides a fundamental structure and common functionalities that ensure consistency and ease of use across diverse machine learning models. D. All of the above. An estimator is a machine learning model that learns from data and makes predictions. In scikit-learn, estimators are objects that implement the fit and predict methods. Example: a linear regression model is an estimator that learns a linear relationship between features in a target variable and uses this relationship to make predictions on new data. A transformer is a machine learning model that transforms data from one representation to another. In scikit-learn, transformers are objects that implement the fit and transform methods. Example: standard scaler is a transformer that scales features to have zero mean and unit variance. Hyperparameters are parameters that control the learning process of a model. They are not learned from the data but set by the user. In a linear regression model, the regularization parameter alpha is a hyperparameter. It controls the trade-off between model complexity and bias. The fit method of an estimator trains the model on the input data. It learns the parameters of the model that best fit the data. In a linear regression model, the fit method learns the coefficients of the linear equation. The predict method of an estimator uses the trained model to make predictions on new data. In a linear regression model, the predict method uses the learned coefficients to predict the target variable for new input. Features. Model selection is the process of choosing the best model for a given task. This involves selecting the right model type and tuning the hyperparameters. Selecting a logistic regression model for a binary classification problem and tuning a regularization strength. Model evaluation is the process of assessing the performance of a model on unseen data. It helps determine the model's accuracy and generalizability, using metrics like accuracy, precision, recall, and F1 score to evaluate the performance of a classification model. Pipelines are a way to chain multiple estimators together. They allow for sequential processing of data, making model development more efficient. A pipeline that first scales features using standard scaler and then trains a linear regression model, which is a key characteristic of the bicluster mixin class in scikit-learn. A. It implements the fit method for biclustering algorithms. B. It defines the bicluster's attribute to store the bicluster results. C. It allows for easy access to the row and column indices of biclusters. D. All of the above. Correct. The fit method is a fundamental part of any machine learning model. Including biclustering algorithms, this method takes the input data and trains the model to find A. Biclusters. The bicluster mixin class provides this functionality. Fit method. Correct. Once the model is trained using the fit method, it stores the results of the biclustering process in the bicluster's attribute. This attribute typically contains information about the biclusters found, such as the row and column indices belonging to each bicluster. Bicluster's attribute. Correct. After the biclustering process is complete, accessing the row and column indices of the biclusters is crucial for understanding the data structure and interpreting the results. The bicluster mixin class facilitates this access. Row and column indices. Correct. The bicluster mixin class in scikit-learn implements all the mentioned characteristics. It has a fit method for training the model, the bicluster's attribute to store the results, and provides easy access to the row and column indices of the biclusters. Biclustering with scikit-learn. D. All of the above. Biclustering is a technique used to identify subgroups of rows and columns in a data matrix that exhibit similar behavior. It's useful in uncovering hidden patterns in data where traditional clustering might fail. Gene expression analysis, identifying co-regulated genes in gene expression data. Document clustering, grouping documents based on shared themes or topics. Market basket analysis, identifying products that are frequently bought together. Image analysis, identifying regions of interest in images based on similar features. Social network analysis, discovering communities or groups of individuals who share common interests. Let's say we have a dataset of gene expression data with rows representing genes and columns representing different conditions. Using biclustering, we might find that certain genes are upregulated under specific conditions, forming a bicluster. This pattern might indicate a biological pathway that is activated under those conditions. Biclustering. The fit method is fundamental to any machine learning model. Including biclustering algorithms, it takes the input data and trains the model to find A. Biclusters. Fit method. The bicluster's attribute stores the results of the biclustering process. It typically contains information about the biclusters found, such as the row and column indices that belong to each bicluster. Bicluster's attribute. Accessing the row and column indices of biclusters is crucial for understanding the structure of the data and interpreting the results of the biclustering process. Row and column indices. Which methods are guaranteed to be present in all classes that inherit from sklearns? Classifier mixin. A. Fit. B. Predict. C. Score. D. All of the above. The fit method is essential for training a classifier. It takes training data as input and adjusts the model's internal parameters to learn the relationships between features and target labels. True. Classifier mixin. The predict method is used to make predictions on new data. It takes a set of features as input and outputs the predicted class labels based on the trained model. True. Classifier mixin. The score method evaluates the performance of the trained classifier. It typically uses a predefined metric, e.g., accuracy, precision, recall, to assess how well the model generalizes to unseen data. True. Classifier mixin. All three methods fit, predict, and score are fundamental to the functionality of classifiers that inherit from the classifier mixin. These methods provide a standardized interface for training, predicting, and evaluating models. True. Classifier mixin. D. All of the above. A classifier is a machine learning model that predicts the class label category of a given data point. A spam filter uses a classifier to classify emails as either spam or not spam. Let's consider a simple example where we want to classify emails based on the presence of certain keywords. We can represent the features as binary values: 1 for presence, 0 for absence for keywords like free, money, urgent, and discount. The target label is binary: 1 for spam, 0 for not spam. A classifier model could learn the relationship between these keywords and the spam label, allowing it to predict whether a new email is spam or not. A mixin is a class that provides a set of methods or attributes that can be reused by other classes. In the context of sklearn, classifier mixin provides common methods for classifiers. By inheriting from classifier mixin, different classifier models can utilize the same set of methods for training, prediction, and evaluation, leading to consistent code and easier maintenance. Imagine we have different types of classifiers, such as logistic regression, decision tree, and naive Bayes. Each of these classifiers might have its own internal mechanisms for training and making predictions. However, by inheriting from classifier mixin, they can all share the same fit, predict, and score methods, making their integration and usage more consistent. Inheritance is a key concept in object-oriented programming, where a class can inherit properties and methods from its parent class. In sklearn, different classifier implementations like logistic regression, decision tree classifier, and random forest classifier inherit from classifier mixin to inherit common classifier methods. Think of a mathematical function f(x)(x2). A new function g(x2)(x21) can inherit the squaring operation x2 from fx and add its own modifications 2 by 2 1. Similarly, in inheritance, a child class inherits properties from a parent class and can extend or modify them as needed. Method overriding allows a subclass to provide its own implementation of a method inherited from a parent class. While all classifiers inherit the score method from classifier mixin, they can override its implementation to use specific evaluation metrics that are relevant to their particular algorithm. Consider a function calculate area. A square class could override this method to calculate area as side 2, while a circle class could override it to calculate area as radius 2. What does the sklearn base cluster mixin class provide? An abstract base class for clustering algorithms, a concrete clustering algorithm, a set of utility functions for clustering. All of the above. The base cluster mixin in sklearn is an abstract base class that defines common methods and attributes expected from clustering algorithms. True. Furthermore, it serves as a base for concrete clustering algorithms in sklearn, which inherit from base cluster mixin. True. It also provides utility functions like fit predict to facilitate common clustering tasks. True. The correct answer is LTBGTD. LTBGT. True. D. Clustering is a machine learning technique that involves grouping similar data points together based on their characteristics. The goal is to discover hidden patterns and structures within the data. K-means is a popular clustering algorithm that partitions data points into K-clusters based on their distances from the cluster centroids. It iteratively updates the centroids to minimize the within-cluster sum of squares WCSS. DBSCAN density-based spatial clustering of applications with noise is a density-based clustering algorithm that identifies clusters as areas of high density separated by areas of low density. It's effective for handling clusters of irregular shapes and noisy data. Agglomerative clustering is a hierarchical clustering technique that starts by considering each data point as a separate cluster and iteratively merges the closest clusters until a desired number of clusters is reached. It creates a dendrogram representing the hierarchical structure of the clusters. An abstract base class ABC defines a common interface for derived classes but doesn't provide concrete implementations for all methods. It ensures that derived classes implement specific methods or attributes, promoting code consistency and extensibility. Inheritance is a fundamental object-oriented programming concept where a new class-derived class inherits properties and behaviors from an existing class-base class. It allows for code reusability and building upon existing functionality. The fit-predict method combines the fit and predict methods in one step. It fits the clustering model to the data and immediately predicts the cluster labels for each data point. The predict method takes new data points as input and predicts their cluster labels based on a trained clustering model. It assumes the model has already been trained on the training data. Building your own custom clustering algorithms by inheriting from base cluster mixin. You can create your own specialized clustering algorithm that caters to specific requirements by inheriting from base cluster mixin. This ensures that your custom algorithm adheres to common conventions and interfaces defined by the base class. Utilizing pre-built clustering algorithms that are based on base cluster mixin for standardized interfaces and functionalities. Sklearn's K-means, DBSCAN, and agglomerative clustering algorithms inherit from base cluster mixin. This guarantees consistency in how these algorithms are used, allowing for seamless integration within your project. Consider a dataset of customers' shopping history with features like age, income, and purchase frequency. We want to cluster customers into groups based on their purchasing behavior. We can use K-means with n clusters 3 to create 3 clusters. 25, 5,000, 10, 35, 7,000, 15, 45, 9,000, 20, 28, 6,000, 12, 38, 8,000, 18, 48, 1,000, 25, 22, 4,000, 8, 32, 650, 13, 42, 850, 19. K-means. The K-means algorithm would identify 3 clusters, potentially grouping younger customers with lower income and less purchase frequency, middle-aged customers with moderate income and purchase frequency, and older customers with higher income and frequent purchases. Which of the following is true about the sklearn base density mixin class in scikit-learn? A. It provides a scoresamples method for calculating the density of data points. B. It is a mixin class that can be used to add density estimation capabilities to other scikit-learn estimators. C. It requires the fit method to be implemented in the inheriting class. D. All of the above. This is true. The density mixin class provides the scoresamples method, which calculates the probability density of each data point based on the learned distribution. Sklearn's method. This is true. The density mixin class acts as a mixin, allowing you to inherit its capabilities for density estimation into other scikit-learn estimators. Mixin class. This is false. The density mixin doesn't force the inheriting class to implement the fit method. This gives flexibility to adapt the fitting process to different estimator requirements. Fit method. This is true. All the statements in choices A, B, and C are true about the density mixin class. Answer. D. All of the above. Density estimation. Density estimation involves estimating the probability density function of a dataset, which allows you to understand how likely a given data point is to occur within the data distribution. Anomaly detection. If a data point has a low density, it's likely an outlier anomaly. This helps identify unusual or suspicious events, like fraudulent transactions or machine failures. Mixin class. Mixin classes provide a way to add reusable functionalities to other classes without inheriting from them directly. This avoids multiple inheritance issues and promotes modularity. Adding scalability in scikit-learn. You can use a standard scalar mixin to add scaling capabilities to your custom estimator. Sklearn's method. The Sklearn's method, provided by the density mixin, calculates the density of each data point, providing an estimate of its likelihood within the data distribution. Density-based clustering. You can use Sklearn to identify regions of high density, indicating clusters of similar data points. Fit method. The fit method in scikit-learn estimators is responsible for training the model on the provided data. It typically learns the parameters of the model based on the input data. Training a logistic regression model. You would call fit on a logistic regression object to train it to predict binary outcomes based on your input data. Consider a dataset of house prices. Using a density estimation technique, you can estimate the probability density function of house prices. This will help you determine the likelihood of finding a house at a particular price. For example, if the density for houses priced at $500,000 is high, it suggests a high probability of finding houses at that price point. Here's a sample dataset of house prices in thousands of $350, $420, $480, $500, $510, $550, $600, $700. Which of the following is not a fundamental method associated with scikit-learn's base regressor mixin? A. Fitx, Y. B. Predictx, C. ScoreX, Y. Sample weight none. D. TransformX, Fitx, Y. Trains the model on the given data X features. Y. Targets, use case, learning the relationship between house features and price. Correct. The Fitx, Y method is essential for training a regression model in scikit-learn. It takes the features X and the corresponding target values Y as input and uses them to learn the relationship between them. This method is fundamental to all regression models based on regressor mixin. Predictx generates predictions for new data X features. Use case, predicting the price of a new house based on its features. Correct. The Predictx method is used to make predictions on new data points. It takes the features X of the new data as input and uses the learned relationship from the fit method to generate predictions. It's a fundamental part of the regression process. ScoreX, Y, sample weight none, evaluates the model's performance on the given data X features. Y targets, use case, assessing how well the model predicts house prices on a test dataset. Correct. The ScoreX, Y, Sample weight none method is used to evaluate the performance of a trained regression model. It takes the features X and the corresponding target values Y as input and calculates a score based on a chosen evaluation metric. This method helps to assess the model's accuracy and effectiveness. None. Incorrect. The TransformX method is typically associated with dimensionality reduction techniques or feature extraction, which are common in machine learning, but not directly related to the core functionalities of a regressor. Regressor mixin is designed for regression, not transformation. D. TransformX. LT font color co 0000FF quotient regress or mixed font GT. Key principles. 1. Fundamental interface for regression tasks. 2. Defines core methods fit, predict, score. 3. Provides a common framework for regression models. Regressor mixin is a fundamental class in scikit-learn that defines the basic interface for regression tasks. It provides core methods like fit, predict, and score, which are essential for building and evaluating regression models. This mixin helps to standardize the way different regression models are implemented in scikit-learn, offering a common framework for regression. Fit X, Y, trains the model on the given data X features. Y targets, use case, learning the relationship between house features and price. The Fit X, Y method is used to train the model on the given data. It learns the relationship between the input features X and the target values Y. For example, in the case of predicting housing prices, this method would learn how features like size, location, and amenities influence the price of a house. Predict X generates predictions for new data X features. Use case, predicting the price of a new house based on its features. Once the model is trained, the PredictX method is used to generate predictions for new data points. It takes the features X of the new data as input and uses the learned relationship from the fit method to generate predictions. In the housing price example, it would predict the price of a new house based on its features. Score X, Y, sample weight none, evaluates the model's performance on the given data X features. Y targets, use case, assessing how well the model predicts house prices on a test dataset. The Score X, Y, sample weight none method evaluates the performance of the trained model. It takes features X and target values Y as input and calculates a score based on an evaluation metric. This metric could be mean squared error, R squared, or any other suitable metric for regression. The score helps to assess the accuracy of the model's predictions. 1. Predicting housing prices. Features size, location, amenities. Target price. This is a classic regression use case. You train a model on data containing features like house size, location, and amenities, and the corresponding price. The model learns the relationship between these features and the price, allowing you to predict the price of new houses with similar features. 2. Forecasting stock market trends. Features historical stock data, economic indicators. Target future stock prices. Regression can be used to forecast stock prices based on historical stock data and relevant economic indicators. This allows investors to make informed decisions about buying, selling, or holding stocks. Models can be built to identify trends and patterns in stock price movements, leading to better market predictions. 3. Estimating customer lifetime value (CLV). Features customer purchase history, demographics, target total revenue a customer will generate. Customer lifetime value (CLV) is a crucial metric for businesses. Regression models can be used to estimate a customer's future revenue generation potential based on their purchase history, demographics, and other relevant features. This information is valuable for targeted marketing and customer retention strategies. 4. Predicting customer churn. Features customer interactions, usage patterns, target probability of a customer leaving. Customer churn is a significant issue for businesses. Regression models can be used to predict the likelihood of a customer leaving based on their interactions with the company, usage patterns, and other relevant factors. This allows businesses to identify at-risk customers and take proactive measures to retain them. 5. Analyzing sales data. Features product features, market trends, target sales volume. Regression models can be used to analyze sales data and identify factors that influence sales volume. Features like product features, market trends, and marketing campaigns can be used to predict sales volume, helping businesses optimize their marketing strategies and product offerings. Which of the following is not a method provided by the sklearn base regressor mixin? A. Fitx, Y. B. Predictix. C. Score X, Y. Sample weight none. D. Transform X. A. Fitx, Y. The Fitx, Y method is used to train the regressor model on the input features X and target values Y. This method is a fundamental part of the training process for any machine learning model, including regressors. It is used to find the optimal parameters that minimize the difference between predicted and actual values. Regressor mixin. In predicting house prices, you would use the Fitx, Y method to train a regression model on historical house data with features like size, location, and number of bedrooms, and the target variable as house prices. Let's say you have a simple linear regression model to predict house prices based on square footage. Your data might look like this. Square footage x house price y. Dash 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 dash. 1500 250,000. 2000 300,000. 2500 350,000. You would use the Fitx, Y method to train the model on this data. This would calculate the coefficients of the linear equation that best fit the data, allowing the model to make predictions on new house data. B. Predictix. The Predictix method is used to make predictions on new input features X after the model has been trained using the Fitx, Y method. This method is essential for applying the trained model to unseen data and generating predictions. Regressor mixin. After training a house price prediction model using Fitx, Y, you can use the Predictix method to estimate the price of a new house given its features like size, location, and number of bedrooms. Let's say your trained linear regression model for house price prediction has the equation house price 100,100 square footage. To predict the price of a new house with 2,200 square feet, you would use Predictix house price 100,100 2200 320,000. C. Score X, Y, sample weight none. The Score X, Y, sample weight none method is used to evaluate the performance of the trained regressor model on A. Input features X and target values Y. It provides a measure of how well the model is able to predict the target values. This method is crucial for assessing the accuracy and effectiveness of the model. Regressor mixin. In evaluating your house price prediction model's performance, you can use the Score X, Y method to calculate metrics like mean squared error or R squared. These metrics help you understand how well the model fits the data and its ability to predict house prices accurately. Let's say your house price prediction model's Score X, Y returns an R squared value of 0.8. This means that 80 of the variation in house prices can be explained by the model, indicating a good fit. A higher R-squared value generally suggests better predictive power. D. TransformX. The TransformX method is not a method provided by the sklearn Bayes regressor mixin. It is associated with transformers. It's used to transform the input features X. A common example is scaling features to a common range. Transformer mixin. Before training a house price prediction model, you might use a standard scalar transformer to scale features like square footage and number of bedrooms to have a mean of 0 and standard deviation of 1. This can improve model performance by standardizing the input data. Let's say your square footage data ranges from 1000 to 3000. Using a standard scalar to transform this data would rescale the values to have a mean of 0 and standard deviation of 1. This can help prevent features with larger scales from dominating the model. D. TransformX. Which statement best describes sklearn's transformer mixin? An abstract class that defines the fit and transform methods, essential for data transformation in machine learning pipelines. A concrete class that performs dimensionality reduction, extracting the most significant features from data. An interface that ensures consistency in data preprocessing steps, allowing seamless integration with pipelines. A utility function that handles data scaling and normalization, preparing data for model training. An abstract class that defines the fit and transform methods, essential for data transformation in machine learning pipelines. True. Correct. Transformer mixin is an abstract class in sklearn. It defines the fit and transform methods. These methods are crucial for data transformation tasks. The fit method learns the transformation parameters from the training data. The transform method applies the learned transformation to new data. These methods are essential for data preprocessing and feature engineering, making it suitable for machine learning pipelines. A concrete class that performs dimensionality reduction, extracting the most significant features from data. True. Correct. While transformer mixin doesn't directly perform dimensionality reduction, classes like PCA principal component analysis and truncated SVD inherit from transformer mixin. Implementing dimensionality reduction techniques, they leverage the fit and transform methods to learn and apply dimensionality reduction on data. An interface that ensures consistency in data preprocessing steps, allowing seamless integration with pipelines. True. Correct. Transformer mixin acts as an interface. By implementing transformer mixin, you create classes that can be seamlessly integrated into sklearn pipelines, ensuring consistent preprocessing steps. This simplifies building complex machine learning workflows. The fit and transform methods ensure that data is consistently preprocessed, making pipelines more robust. A utility function that handles data scaling and normalization, preparing data for model training. True. Correct. While not a utility function itself, transformer mixin is used to build classes like standard scalar and min-max scalar. These classes handle data scaling and normalization, preparing data for model training by scaling features to a common range or distribution, which improves model performance. All the above. Data preprocessing. Data preprocessing involves transforming raw data into a format suitable for machine learning models. It includes tasks like handling missing values, scaling features, and encoding categorical variables. Transformer mixin is a core component in data preprocessing. Feature engineering. Feature engineering involves creating new features or modifying existing ones to improve model performance. Transformer mixin is used to create custom transformers that can engineer new features based on data. Machine learning pipelines. Machine learning pipelines streamline machine learning workflows by combining different preprocessing steps and model training into a single sequence. Transformer mixin allows seamless integration of data transformation steps into pipelines, making them more efficient. Abstract classes. Abstract classes in object-oriented programming define a template for other classes. They can have abstract methods that must be implemented by subclasses. Transformer mixin is an abstract class that defines the fit and transform methods, which are implemented by concrete classes. Interfaces. Interfaces in object-oriented programming define a set of methods that must be implemented by classes. Transformer mixin acts as an interface, ensuring that any class implementing it will have the fit and transform methods, enabling consistent integration into pipelines. Fit and transform methods. The fit method learns the transformation parameters from the training data, and the transform method applies the learned transformation to new data. These methods are crucial for data preprocessing and feature engineering, and they are defined by transformer mixin. Which of the following statements accurately describes the role of the method estimator mixin? Method estimator mixin in scikit-learn. A. It provides a base class for building custom estimators that combine multiple estimators. B. It enables the creation of estimators that can learn from data with different data types. C. It's used for defining estimators that automatically select the best hyperparameters for a given model. D. All of the above. Correct. The method estimator mixin indeed acts as a base class to construct custom estimators, allowing you to combine multiple estimators. This enables the creation of complex models by combining the strengths of different estimators. The method estimator mixin allows you to create custom estimators that incorporate other estimators as components. This opens up possibilities for building complex pipelines, ensemble methods, and stacking strategies. Correct. The method estimator mixin facilitates the building of estimators that can handle diverse data types, including numerical, categorical, and text data. This versatility makes it ideal for tackling real-world machine learning problems involving heterogeneous datasets. The method estimator mixin allows you to build estimators that can process data with different formats, such as numerical, categorical, or text data, making it versatile for various machine learning tasks. Correct. While not directly responsible for hyperparameter tuning, the method estimator mixin provides the framework to create estimators that can effectively leverage hyperparameter optimization techniques like grid search CV and randomized search CV. While not directly responsible for hyperparameter tuning, the method estimator mixin lays the groundwork for creating estimators that can leverage advanced optimization techniques like grid search CV or randomized search CV. Correct. As explained above, all statements A, B, and C accurately describe the roles of the method estimator mixin, making option D the correct answer. The method estimator mixin is a crucial part of scikit-learn's flexible estimator framework. It lays the foundation for creating complex estimators that can combine multiple other estimators, handle diverse data types, and even incorporate automatic hyperparameter tuning. D. All of the above. Estimators. Estimators are fundamental building blocks in scikit-learn. They represent algorithms capable of learning patterns from data and making predictions. Examples include linear regression, decision trees, and support vector machines. In a linear regression model, the estimator learns the coefficients of a linear equation to best fit the relationship between independent and dependent variables. For example, You might use a linear regression estimator to predict a house's price based on features like size and location. Pipeline. Pipelines are sequences of estimators that can be chained together to perform a series of data transformations and modeling tasks. They simplify and streamline machine learning workflows. You could create a pipeline for image classification that first preprocesses the image data resizing, normalization, then applies a convolutional neural network for feature extraction, and finally uses a classifier to make predictions on the extracted features. Ensemble methods. Ensemble methods combine multiple individual estimators to improve prediction accuracy and robustness. Popular ensemble techniques include random forests and gradient boosting machines. A random forest combines multiple decision trees, each trained on a random subset of the data, to make predictions. This ensemble approach often leads to better generalization and avoids overfitting. Hyperparameter tuning. Hyperparameters are parameters of a machine learning model that are not learned from data but instead set before training. Hyperparameter tuning involves finding the optimal values for these parameters to maximize model performance. In a support vector machine SVM, a key hyperparameter is the C parameter, which controls the trade-off between fitting the training data and allowing for misclassifications. Tuning the C parameter to an appropriate value can significantly impact the SVM's accuracy and ability to generalize to unseen data. Grid search CV. Grid search CV is a hyperparameter optimization technique that exhaustively searches a grid of parameter values, fitting the model with each combination and evaluating its performance. Suppose you want to find the best C and gamma parameters for an SVM. Grid search CV would try all combinations of values within specified ranges for these parameters and report the combination that results in the highest accuracy on a validation set. Randomized search CV. Randomized search CV is similar to grid search CV, but instead of trying all combinations, it samples random combinations from the parameter space, making it computationally less expensive, particularly when dealing with a large number of hyperparameters. If your SVM has many hyperparameters to tune, randomized search CV can efficiently explore a wide range of combinations, potentially finding a good solution without exploring the entire parameter space. What is the primary role of the one-to-one feature mixin in scikit-learn? And what are some key considerations when using it? A. It facilitates data dimensionality reduction by merging multiple features into a single one. B. It transforms a single feature into a set of new features, enhancing the model's complexity. C. It enables the creation of new features by combining existing ones, often using nonlinear transformations. D. It ensures a one-to-one correspondence between input and output features, preserving the original feature space. E. It automatically detects and handles missing values in the dataset. D. The one-to-one feature mixin is designed to ensure that each input feature is transformed into exactly one output feature, preserving the original dimensionality of the data. This is crucial when you need to create a new feature that is directly derived from an existing one, without altering the structure of your dataset. It's commonly used in scenarios where you need to apply transformations to features while maintaining a one-to-one correspondence between input and output features, preventing unintended changes to the feature space. Dimensionality reduction is about reducing the number of features, not merging them. This is the opposite of what one-to-one feature mixin does. Transforming a single feature into multiple features is called feature expansion, not the role of one-to-one feature mixin. It aims to maintain the original dimensionality, Creating new features by combining existing ones falls under the category of feature engineering. However, one-to-one feature mixin focuses on preserving the original feature space, not creating new ones. Handling missing values is a separate task in data preprocessing, not the primary function of one-to-one feature mixin. Feature engineering, creating new features from existing ones, often involving transformations, to improve model performance. Dimensionality reduction, reducing the number of features in a dataset to simplify modeling and improve performance. Feature scaling, transforming features to have a similar scale to prevent bias in model learning. Feature selection, choosing a subset of relevant features to improve model performance and reduce complexity. Applying logarithmic transformations, transforming skewed features to a more normal distribution using a logarithm. Example: transforming a feature representing income to its logarithmic counterpart to address its skewed distribution. Suppose you have a feature representing income with values like 10,000, 2,000, 5,000, 1,000. The distribution is skewed. Applying a logarithmic transformation, e.g., using np.log would give you 9.21, 9.90, 10.82, 11.51, leading to a more balanced distribution. Feature standardization, scaling features to have zero mean and unit variance. Example: transforming features like height and weight to have a mean of 0 and a standard deviation of 1. Consider features like height 160, 175, 180, 190 and weight 60, 75, 80, 90. To standardize them, subtract the mean 176.25 for height, 76.25 for weight and divide by the standard deviation 10.69 for height, 12.91 for weight to get standardized values close to 0. How is sklearn, Bayes, outlier mixin used in outlier detection? It directly identifies outliers using its fit method. It provides a base class for outlier detection estimators. It calculates outlier scores using the decision function method. All of the above, false. While the fit method is used to train the estimator, outlier mixin itself doesn't directly identify outliers. Instead, it provides a base class for estimators that can be trained to detect outliers. The fit method trains the model, and then a decision function is needed to identify outliers. Outlier mixin, true. This statement is correct. Outlier mixin serves as a base class for outlier detection estimators in scikit-learn. It defines common functionalities for outlier detection models. Outlier mixin, true. This is also correct. Outlier mixin defines the decision function method, which calculates the outlier scores for each data point. These scores can be used to identify outliers by setting a threshold. Decision function, true. All the statements above are correct. Outlier mixin provides a base class, uses the fit method for training, and offers the decision function method for outlier score calculation. Outlier mixin, D. All of the above. The process of identifying data points that significantly deviate from the expected pattern or distribution in a dataset, a broader term that encompasses outlier detection as well as other techniques for identifying unusual patterns or behaviors in data. A field of computer science that focuses on developing algorithms that can learn from data. A type of machine learning where the algorithm learns from labeled data, where the desired output is known. A type of machine learning where the algorithm learns from unlabeled data, without prior knowledge of the desired output. The process of identifying and correcting errors or inconsistencies in data, which can include outlier removal. Fraud detection in financial transactions, identifying unusual spending patterns or transactions that might indicate fraudulent activity. Anomaly detection in network traffic, detecting suspicious network activity that could indicate a cyber attack or intrusion. Identifying unusual data points in sensor readings, finding sensor readings that deviate significantly from expected values, potentially indicating equipment failure or malfunction. Detecting defective products in manufacturing, identifying products that don't meet quality standards based on sensor data or other measurements. Identifying outliers in image datasets, finding images that are significantly different from other images in a dataset, potentially indicating errors or misclassifications. 1, 2, 3, 4, 5, 100. In this dataset, the value 100 is an outlier. An outlier detection algorithm would identify it by calculating a measure of distance from other data points or by using statistical methods to determine if it is significantly different from the rest of the data. Which of the following statement accurately describes the sklearn base class name prefix features out mixin class? A. This mixin class provides a way to automatically add a prefix to the output features of any estimator it is mixed in with. B. This mixin class is used to handle the transformation of input features before passing them to an estimator. C. This mixin class is responsible for creating a new estimator that combines the functionality of two existing estimators. D. All of the above. This statement is correct. The class name prefix features out mixin class in scikit-learn is designed to add a prefix to the names of output features generated by an estimator. This is particularly useful for managing feature names in pipelines involving multiple estimators, ensuring that features are uniquely identified and organized. This mixin class provides a way to automatically add a prefix to the output features of any estimator it is mixed in with. This statement is incorrect. The class name prefix features out mixin doesn't directly handle input feature transformations. This is generally handled by transformers like standard scalar, one-hot encoder, etc., which operate on input data before it's passed to an estimator. This mixin class is used to handle the transformation of input features before passing them to an estimator. This statement is incorrect. Combining the functionality of two estimators is typically done using pipeline, feature union, or custom classes that inherit from base estimators. The class name prefix features out mixin is not involved in this process. This mixin class is responsible for creating a new estimator that combines the functionality of two existing estimators. This statement is incorrect. Only statement A is correct. The class name prefix features out mixin focuses solely on prefixing output feature names. All of the above. A. Mixin classes are special classes that provide methods for other classes to inherit. They act as a way to extend the functionality of existing classes without needing to create entirely new classes. In scikit-learn, mixins are frequently used to enhance the capabilities of estimators. For instance, the class name prefix features out mixin is a mixin that augments estimators by enabling them to add prefixes to their output features. Imagine you have a pipeline where a standard scalar is followed by a logistic regression estimator. The mixin allows you to label the output features of the logistic regression estimator with a prefix like LR to distinguish them from the scaled features. In a more complex pipeline, you might have multiple feature extraction steps. The mixin can add prefixes to the features produced by each step, helping you track their origins and understand their relationships to the final predictions. Estimators form the heart of scikit-learn. They are responsible for learning patterns from data and making predictions. There are two primary types of estimators: transformers, which modify input features, e.g., standard scalar, PCA, and predictors, which make predictions based on trained patterns, e.g., logistic regression, random forest classifier, using a decision tree classifier to classify customer churn based on historical data. Utilizing a linear regression model to predict the price of a house based on its size, location, and other features. Applying PCA to reduce the dimensionality of a dataset with a large number of features. Simplifying analysis and improving model performance. Pipelines are essential for building complex machine learning workflows. They allow you to chain multiple estimators together, streamlining the process of data preparation, feature engineering, and model training. This promotes modularity and reproducibility, making it easier to manage and modify your machine learning projects. Combining a standard scalar, a polynomial features transformer, and a linear regression estimator into a single pipeline for predictive modeling. Building a natural language processing pipeline that involves text preprocessing, feature extraction, and a classification model for sentiment analysis. Creating a pipeline for image recognition that includes image resizing, feature extraction using a convolutional neural network, and a classification model. What is the primary purpose of the base estimator class in scikit-learn? A. To define a common interface for all estimators, ensuring consistency and interoperability. B. To provide default implementations of essential estimator methods, like fit and predict. C. To handle data preprocessing and feature scaling before model training. D. To manage the hyperparameters of an estimator, allowing for efficient model tuning. E. All of the above. True. The base estimator class defines a standard structure for all estimators in scikit-learn, ensuring that they have consistent methods and attributes. This promotes interoperability and ease of use. For example, all estimators are expected to have a fit method for training and a predict method for making predictions. Key concepts. Estimators. True. The base estimator class often provides default implementations of essential methods like fit and predict. These implementations can be overridden in subclasses for specific estimator types. Key concepts. Estimators. False. Data preprocessing and feature scaling are typically handled by separate classes in scikit-learn, such as standard scalar, min-max scalar, and one-hot encoder. The base estimator class itself does not directly handle these operations. Key concepts. Estimators. False. Hyperparameter management is often handled by techniques like grid search CV or randomized search CV. The base estimator class itself does not provide specific functionalities for hyperparameter optimization. Key concepts. Estimators. True. The base estimator class serves all the purposes mentioned in the previous choices. It establishes a common interface, provides default method implementations, and facilitates consistent interaction across different estimators. Solution. Estimators. E. All of the above. Algorithms that learn patterns from data. Linear regression, logistic regression, decision trees, support vector machines, etc. Building predictive models for various tasks like stock price prediction, customer churn analysis, image classification, etc. Key concepts. Solution. Trains the estimator on input data, learning model parameters. In linear regression, fit would determine the slope and intercept of the best fit line. Training a model to learn patterns and relationships from the data. Key concepts. Makes predictions on new data based on the learned model. Given a new input feature, a trained linear regression model would use the learned slope and intercept to predict the target value. Making predictions on unseen data using the trained model. Key concepts. Ensures all estimators share the same methods fit, predict, score, etc. Simplifying usage and integration. Using the same fit and predict methods for a linear regression model and a decision tree model. Creating modular and easily interchangeable machine learning components. Use cases. Provides basic functionality for common tasks, reducing boilerplate code for developers. The base estimator class provides a default fit method, which can be customized by specific estimators. Simplifying the development process of new estimators by providing common groundwork. How can you determine if a scikit-learn estimator is a classifier using its API? The quiz question is asking about how to identify whether a scikit-learn model is designed for classification tasks by using the available methods and attributes within the scikit-learn API. Check the model's score attribute. The score attribute is used to evaluate a model's performance, but it doesn't provide information about whether the model is a classifier or not. Both classifiers and regressors can have a score attribute. False. Inspect the model's predict_proba method. The predict_proba method is commonly associated with classifiers. It returns the probability of each class for a given input. However, some regressors might also have a similar method for returning probability distributions. Therefore, the presence of predict_proba doesn't definitively confirm a classifier. False. Use the isClassify method from the base estimator class. The isClassify method is a dedicated attribute within the base estimator class in scikit-learn. It specifically checks whether an estimator is designed to perform classification tasks. This method offers a direct and reliable way to confirm the nature of the estimator. True. Use the isClassify method from the base estimator class. The isClassify method within the base estimator class in scikit-learn directly checks if an estimator is a classifier. Base estimator. Classifier isClassify scikit-learn API. The base estimator class serves as the foundation for all scikit-learn estimators. It provides common functionalities and attributes shared by all estimators, including the isClassify method. A classifier is a type of machine learning model that predicts the class label for an input sample. It aims to categorize data into predefined categories or classes. The isClassify method is specifically designed to determine whether a scikit-learn estimator is a classifier. This method returns true if the estimator is a classifier and false otherwise. The scikit-learn API provides a standardized interface for working with machine learning models. It defines methods and attributes for building, training, and evaluating models, including the isClassify method for identifying classifiers. Model selection. Identify the appropriate model for a classification problem, e.g. logistic regression, SVM. Decision trees by confirming the isClassify property. Debugging. Determine if a custom estimator is functioning correctly for classification tasks. Parameter tuning. Tailor hyperparameters for a classifier by knowing its specific nature. When dealing with classification problems, the isClassify method can help you choose the right model. You can quickly identify which models are designed for classification by checking the isClassify property. For instance, if you want to use a support vector machine SVM for a classification task, you can verify it using isClassify. If you've created a custom estimator for classification, using isClassifier can help you debug its functionality. You can confirm that your estimator is correctly identified as a classifier. Ensuring it's working is expected for the classification task. When fine-tuning the hyperparameters of a classifier, knowing the classifier's nature is crucial. By using isClassifier, you can ensure that you are tuning parameters that are specifically relevant to classification tasks. Avoiding unintended consequences. Consider a dataset with features representing customer demographics in a target variable, indicating whether the customer is likely to make a purchase 1 or not 0. To build a classification model, we can use a logistic regression model from sklearn. Using the isClassifier method on a logistic regression object will return true, confirming that it's a classifier. From sklearn, linear model import logistic regression. Model logistic regression. Print model, isClassifier. What is the purpose of the sklearn base isRegressor function in sklearn? A. Checks if a model is a valid estimator. B. Determines if a model can be used for regression tasks. C. Evaluates the performance of a regression model. D. All of the above. The correct answer is D. sklearn base isRegressor checks whether an estimator is a valid estimator, determines if it can be used for regression tasks, and is a critical tool for ensuring compatibility and proper model selection in sklearn. True. The isRegressor function checks if a model is a valid estimator in sklearn. An estimator is any object in sklearn that learns from data, such as regression models, classification models, or clustering models. This check ensures the model adheres to the basic structure and interface required for model training and prediction. This is essential for ensuring compatibility within sklearn's ecosystem. The correct answer is D. sklearn base isRegressor checks whether an estimator is a valid estimator, determines if it can be used for regression tasks, and is a critical tool for ensuring compatibility and proper model selection in sklearn. True. The primary purpose of isRegressor is to determine if a model is suited for regression tasks. Regression involves predicting continuous values, like predicting house prices based on various features. isRegressor verifies if the model's architecture and algorithms are designed to handle such continuous output predictions. The correct answer is D. sklearn base isRegressor checks whether an estimator is a valid estimator, determines if it can be used for regression tasks, and is a critical tool for ensuring compatibility and proper model selection in sklearn. False. The isRegressor function is not directly involved in evaluating the performance of a regression model. It focuses on checking the model's suitability for regression, not its actual performance. Performance evaluation is typically done using metrics like mean squared error (MSE) or R-squared. The correct answer is D. sklearn base isRegressor checks whether an estimator is a valid estimator, determines if it can be used for regression tasks, and is a critical tool for ensuring compatibility and proper model selection in sklearn. True. The isRegressor function performs all of the actions mentioned in the choices. It checks if a model is a valid estimator, determines if it can be used for regression, and it plays a crucial role in model selection and compatibility within the sklearn framework. D. All of the above. An estimator is a fundamental building block in sklearn. It's any object that learns from data. Estimators can be either supervised, e.g., regression models, classification models, or unsupervised, e.g., clustering models. Building a model to predict housing prices based on features like location and size. Creating a model to classify emails as spam or not spam. Clustering customers based on their purchasing patterns to segment the market. In a housing price prediction model, the estimator learns a relationship between features like square footage X and price Y. The model might be represented as a linear equation y-axis b, where A and B are parameters learned by the estimator from the training data. Regression and classification are two major types of supervised machine learning tasks. Regression deals with predicting continuous values, e.g., predicting house prices, while classification focuses on predicting categorical labels, e.g., classifying emails as spam or not, predicting the price of a stock based on historical data, classifying images as containing cats or dogs, identifying fraudulent transactions based on patterns in spending data. In a regression problem, you might use a linear regression model to predict the price of a house Y based on its size X using an equation like y-axis b. In a classification problem, you could use a logistic regression model to predict if an email is spam Y1 or not spam Y0. Based on its content X, you can use isregressor to check if a given model is appropriate for regression tasks. This helps you choose the right models based on the nature of your prediction problem. Regression or classification. Choosing a linear regression model for predicting stock prices because it's suited for continuous value prediction. Selecting a logistic regression model for classifying email spam because it's appropriate for categorical label prediction. Deciding on a support vector machine (SVM) for image classification because it's effective for high-dimensional data. If you have a dataset with continuous target values, e.g., house prices, and you need to predict them, you would use a regression model. If your target values are categorical, e.g., spam or not spam, you would use a classification model. Isregressor helps validate that your chosen model is compatible with the task you are trying to solve. If you are attempting to use a classifier for regression, Isregressor will help you catch this error, ensuring that a linear regression model, chosen for house price prediction, is indeed a valid regression model before training it. Catching a potential mistake if a classification model is accidentally used for predicting continuous values like stock prices. Checking if the model used for customer segmentation is a clustering model, as intended. Before training a linear regression model y-axis b, you would use isregressor to ensure that the model is designed for predicting continuous values, which are represented by the variable y in the equation. Incorporating isregressor into your code promotes robustness by ensuring that the model you select aligns with your intended task. This helps prevent unexpected errors or incorrect model selection. Including isregressor checks in a machine learning pipeline to prevent the wrong model from being applied to the data. Writing automated tests for your code that verify the models are correctly classified as regression or classification models. Building reusable functions in your code that use isregressor to ensure consistent and correct model usage. Instead of assuming that a model is a regression model, you would use isregressor to confirm it before using it in your prediction equation y-axis b, preventing potential errors and ensuring your results are accurate. Estimators. Supervised learning, unsupervised learning, regression, classification, model selection, model validation, robust code.